All right. Welcome to this Crystallize live stream. Today will be a little bit different one. I got a challenge from Didrik on Friday, where we basically had a discussion of relevance, merchandising, and ranking. How can we do that, and can we do that in a better way? So, Didrik, say hello to the internet, and maybe you can
Hello, internet.
elaborate a little bit more on the challenge you brought to the table.
Yeah, no, and it's always the discussion that we have when, okay, what do we show first? Well, how do you show your products on your commerce site? Should we just sort by alphabetic order? It's the usual way. It's merchandising. You create some recommended things that you would like people to see. Is it based on price? As you can see here, is it race to bottom? Do you show this is our newly added products first? And manual creation, and like we said here, I know that you have something that you want to reveal, board, but the manual creation that you try to create a website that fits basically all without any idea what the user actually wants. So and it doesn't scale well if you have a lot of SKUs.
No, if it's like thousands of products or tens of thousands or hundreds of thousands of products, that is kind of a lot of work if you want to do it manually.
Yep.
And the question you said, what if the catalog ranked itself, right? So long story short, what you see here is a fully ranked storefront based off of intelligence, and it is personalized, and it's no API calls on this, right? So it's super fast. And again, I can show the results. So this is what everybody sees, and if I choose Nirvana, which you of course want to choose, add to the basket, it will re-rank according to your taste. Now, that's the end game. But how did we do that? By the way, this is a repo that we did, AI ranked storefront on the Crystallize GitHub account, where you have this source code. So we open sourced it, and it's basically 3 steps that we'll explain. Is the offline pipeline. We're doing some pre-chewing of data. It's the runtime storefront that is using ranking to display the order of the products. And then it's what we call the client-side taste engine, right? So let's dive into the details here. This will be a little bit nerdy because it is. But the 3 layers. So first is batch ranking. So this is something you can do weekly, daily, hourly, based off of your catalog and perhaps number of transactions and customers. And here we're using the metadata. So which, in this case, it's which vinyl album, which genre, which subgenre, and which band is it, right? And this is being used to rank, is it a known album? Is it something people are buying based off of Claude's memory, right? So using Claude here as a LLM to do that. But we also have purchase signals. This is where we take in the orders, the intent, and the abandoned carts. And this is using the shop API in Crystallize. And we also have the what we call the co-purchase graph. Basically, Didrik bought this, but also these 5 albums. And this is run once, 1 time per day, per week, what have you. And it has 0 runtime cost, right? You use the LLM to pre-generate all of these rankings. And then you have your storefront. Here we're talking pre-computed rankings at startup. No API calls to either Crystallize or Anthropic to generate the storefront, right? So, which means that I can navigate this. It will be instant, and there's 0 API calls, 0 lag for this because it's all pre-computed. kind of like thinking server-side generated or pre-generated pages that you have with Next.js, right? But we're doing it on the data layer.
Yeah, statically hosted, basically.
Yeah, super simple to scale. And then we have the taste engine, which is basically tracking what I am, let's say, adding to the cart. And you say I added Beatles. Beatles will then rank up, or if I add Queen, we will see the ranking is changing in real time. So basically, it takes the taste engine to tweak the recommendations in real time. So it will take what's called the cosine similarity, which is basically we're creating a bunch of vectors, right? So for those that know, that's a value with a direction, right? So Queen will have one direction, Metallica will have another direction. And then if you bought 10 Queen albums or one Queen album, that doesn't really matter, pun intended, because the direction will be the same. The taste is the direction of the vector. So here we basically compare the similarities of the vector angles. We have added what we call decay weighting and co-purchase tuning for this. So basically your profile will live in local storage, and I'll try to explain the different components here. So it still means that, yes, I get real-time recommendations here that is personalized. It's fast, and the overlay that we've done here with ranking, we'll look on that. But that's basically debug, or when we're playing with this to have information on how the scoring is made up. So let's jump to the first part. So this is the first part of the prompt when you want to generate the ranking based on metadata. So here we have, it's back in black AC/DC. We have the signals, 12 carts, 3 of them ordered, 25% conversion ratio. And the co-purchase signals it's bought together with Paranoid and Highway to Hell. And here you get an updated score of this for the whole store based off of what everybody has interacted with. So how popular is it? How well does it convert? And what else do people buy? Claude also is instructed to generate a reasoning here. Iconic hard rock album with strong conversion rate and co-purchase clustering with genre staples. So both with other popular albums. So that's kind of the first part of the static ranking in the offline pipeline. So cron job runs maybe once a day, once a week, depending on your requirements. And then we basically add a taste vector. So if you add some funk records, so James Brown, Parliament, it's a genre funk and subgenre G-funk, and so every product is a vector, and it's simply just in a multi-dimensional space. It's a value with a direction, which means that if 2 products have a close angle, so let's say the Beatles and John Lennon, they're pretty close. It's not the same, but they will have a close vector because they've been bought together many times, and they also have the same kind of genre and subgenre, right? So it matches well. That means a similar taste, and then you get the ranking increased because according to all of our data, this is similar. You don't need to necessarily understand all of the math. That's not the point here. But you have some values that you can use to tweak based off of the learning that you have done. And also, you had a point, Didrik, with what if something is trending, right? As you're all the time on on social media and watch the latest trends as the young alibi in our company.
Young, yeah. No, okay, since we're on the topic of young, what if Justin Bieber just released a new album? It's probably trending really high currently, but in 6 months, it will probably be degraded and not that often bought together, because the hardcore fans probably buy it as soon as it lands.
Yeah.
And then in 6 months, it might not have relevance to your taste score anymore.
While Queen Bohemian Rhapsody will still be a strong performer, right? So it's kind of to differentiate between those. So recent purchase dominate, older signals fade. That's kind of what we've added with Half-Life. So it's exponential drop-off in value, basically, for the scoring of a purchase signal. And this is kind of one of the more important parts here, because typically you want to get products ranked that you haven't bought, or but others have bought, right? So if Didrik has bought the Beatles and John Lennon and Pink Floyd, and I've bought the Beatles, then I will have a proximity or a Jacquard similarity, that is called. Since Didrik has bought something that I bought, but also other things, those other things Didrik have bought will also rank higher for me. So that's a formula that is being used to kind of get. It's the simple. Didrik bought this. You might be interested in what Didrik bought, and then we're doing this over, of course, all orders and order intents, and we'll calculate the weighting for basically product similarities. So that's part of the equation. And finally, you get a relevance score. So, and the point here is that there's no runtime AI, so you don't call Claude or ChatGPT or anything live. There's also no cookies or tracking for this. It's using the shop API, and it's using the pre-calculated ranking information. And the math here is actually done in the browser, so it's kind of fast. So basically, you have the offline relevance score, and then you have the cosine similarity, so comparing angles of your profile with the current product. So did somebody buy this and other products, and all of the things we talked about. And then you have a factor of 0.3. This is where you can tune. This is just a number we used here that had an effect. And essentially that's what's going on here. Let's just take a look at it one more time. The taste here and the debug that you have when you hover, so the bars here, this is obviously something you wouldn't use in production. But essentially you see here that there's some albums that are high performers globally. This is both based on purchase information, but also the general knowledge that Claude has. Since this is music, it knows that Jimi Hendrix is kind of famous. Metallica is the largest heavy metal band, Iron Maiden, etc. So that's kind of the initial ranking that everybody would get. And as soon as you start adding stuff to your cart, it will change the ranking. So here we see the Beatles. I get 2 Beatles album ranked up at top immediately, and then you can continue adding the White Album. Maybe you see some other Beatles, so that you see that it's changing the data in real time. And we will see here that the AI scoring and the cosine similarity, and the similarity is now with what I have in the cart, right? The boosting, and then the final verdict here. So that's essentially it. The taste profile is, again, it's a debug. What are the genres I've bought? What items are added? The Beatles mono. And then you have some of the calculation details in the debug here. So it's pretty cool. I'm thinking the takeaway here is that with the power of Claude, with the definition of the process, you can build this in a quite short amount of time. I spent like an hour on this, to be honest, with the storefront, using Claude Code as a co-pilot here. And you have the architecture, which is, I just want to show a different way of doing this. Yes, you have good APIs, you have good recommendation engines out there, but you can also just use the context and the data to have something that is really tuned towards your products and the way you want your products to be ranked. And it's following the kind of Next.js pre-generated static kind of approach. So this here you can deploy on the CDN and have it, I mean, it's super performant as there's no API calls, similar as a static generated storefront in Next.js. But we have the dynamic taste profile in addition, right? So it will change the ranking in real time based off of what you're adding to the cart or what you're completing if you complete the checkout and purchase.
So in essence, you're using Claude to generate the JSON, like you say here, offline, but kind of online, but not part of the storefront. It's just something you serve the final JSON.
Yep.
Much like if you were to have a static index for search, you could ship that directly to the browser, and the browser does the logic for you.
Exactly. So we're shipping here a bunch of JSON files, which is cached in memory, and then it's generating the routes, and then you adjust it with the client-side taste engine. So this is kind of the clue that you have the data points, you have the vectors, and then you add the taste engine that skews this towards what you're actually interested in or are likely interested in. And then we chose some signals here. I mean, if we look at some of the signals, we see that here we have total cart states. We have the and this is using the shop API in Crystallize, right? The placed, locked, ordered, abandoned. We have the count. We have the total revenue. We have conversion rate, and that is kind of signals from the e-commerce side. And then you have like the rankings in addition, which is kind of relevance score of how relevant is this album, etc. So it's pre-baked data, but that it's tuned in real time so that you get super personalized merchandising in this case. So it takes the merchandising of categories, and it takes the when you click on an album, it takes the recommendations for you. And here we see that we have some other Beatles being ranked up because that's what we've been buying here.
In essence, you could use whatever data you have available. Like if you had some tracking data as well, how many times has people watched the Beatles in mono?
Yeah,
you could add that to add the relevance score as well.
Yeah, and then clicks, click tracking, how long you stayed at the. So you can add any signal you like, and of course, if you're selling not vinyl, you would add other dimensions. What's important for the product? Is it like if you're looking at power tools, are you just looking at the Vault, or are you looking at Festool? Are you then going to recommend Makita, or so that you kind of get that in place. Of course, it doesn't take into account everything. New products, for example, you probably want to add something to boost them. That's typical in recommendation engines, so that we have the recommendation, but then we're trying with some new products to see if you're actually liking them also, so that it will self-learn over time. So anyway, I think it's a cool thing. This is built also using the Crystallize MCP. So that's how we're getting the queries and the communication with Crystallize setup and the Crystallize context. And if you want to check it out, it's available on GitHub. It's a simple thing, but quite interesting approach, I would say. So if you have any questions or comments, feel free to join our Slack community. We will do another live stream next week. If you want to be notified.
See that one? You need to subscribe.
Have a good one. Thanks for watching.
Have a good